Hi guys, so this is for my English, my film studies class that I'm in. We have to do a grad cap project since I'm a senior, and so this is what I'm doing for part of mine, is I'm going to give this presentation about just general like horn maintenance and also some repair stuff, like stuff you can do yourself if you're having issues so that maybe you don't have to go out and spend a bunch of money at a repair tech or something like that. But yeah, so first I'll start with general maintenance. And I'll go over the importance of not using different kinds of greases and oils. So basically, you have two different kinds of greases and oils. You have synthetic and you have non-synthetic. All of them are essentially like petroleum-based or just oil-based. But when you get the natural kinds, there is different sizes of the oil particles. And so over time, the smaller particles can sort of evaporate off of the surface and leave the larger ones behind, and it'll create this sort of gunk almost. And that in combination with the synthetic, which has essentially uniform particle size, means that they don't really mix well together. So it's just generally good practice to use the same kinds of grease, and also, in my opinion, to use synthetic oil, which I think most people probably do. And then in terms of what brands are good, personally, the main ones that I go to, I don't really think any others are super great, is Hetman, number one. I'm sure most, if not all of you guys know of Hetman. They sell everything pretty much. They sell stuff for woodwinds, for brass instruments, everything. And then there's also what I've been using recently is something called Ultra Pure. They don't have quite as many products as Hetman's, but they have some really good like valve/rotor oil that works really well for me. And the main thing with Hetman is that they have a tendency to go out of stock and to run in a shortage, and the Ultra Pure doesn't really do that. So that's why I've been going to them more recently. And then also, grease is really important. And the reason for that is it's not necessarily just so that your stuff, your keys will move fast and so that your slides will slide well. It's because the grease creates an air seal in your horn. So when you don't have things greased properly, the air can leak past things more easily, and it means that your horn won't slot as well, and it just generally won't feel great. So, I mean, not only is it good to oil your horn for the purposes of having it oiled, but also because it'll play much better if it's oiled, not just in the workings of it, but in the actual like buzzing aspect as well.
You want to talk about compression with that?
Yeah, and we can talk about, I'll get out my horn to demonstrate. So, since the valves have oil and the slides have oil, it's meant so that there is a seal. So, like I was saying, so if you were to pull out this slide, it makes a loud popping sound because there's an air seal. However, if I didn't have this greased, or the rotors were really worn out and I was using grease that was too thin, it wouldn't really pop like that. And
what does that mean for playing?
And for playing, that just means that it'll be pretty airy. Okay. And then I'll get into the actual physical mechanics of it. So in your rotor, I won't really talk about this valve stuff because it'll just be extra time and there's nobody here that plays on a valve instrument really. So you have your top bearing, your bottom bearing, and your rotor surface. And to show those, I have this diagram pulled up here. So this is where most people have been taught to oil their keys. So it's just on the top. When you unscrew the cap, there's that little thing. You just put some oil on there. But what a lot of people I found are not often taught is that it is just important to grease the bottom bearing, which is where the stop arm sort of meets. You can't see it super well in this diagram, but where the stop arm meets the bottom of the rotor, there's also a little spindle in here.
So do you want to pull up the photo of the rotors?
Yes. So yeah, you can see right here.
This is from Alex's horn. I just found the soonest rotor picture that I had. So you can see here what Ryan was talking about. These are the bottom spindles and the top spindles, and both of these need to be oiled. Another thing is tapers.
Yeah, we don't really need to get that in depth to it, but each of these things is really tapered so that it will sit well and seal well, because If it were not tapered, over time as it got worn away, there would be no way to fill that gap. But since it is tapered, as it gets worn away, the rotor will actually sit a little bit lower, and that's what can cause sometimes, as your rotors are really old, them to get clicky because they'll move up and down in the casing. And if they didn't do that, then that would just mean that the air seal would be much worse. So yeah, and the last thing that I was going to get into is actually the rotor surface. So there's sort of some conflicting ideas about whether or not you should grease or oil the surface of the rotor, and the way you would do that is by pulling out a slide like this and just putting some oil down here.
Alternatively, some people put the oil in the slide.
Yes, or some people will take their slide like this and they'll get some valve or rotor oil and they'll put it in here, and then they'll take the horn like this and put it back in. So I personally think that it's really important. Sometimes though there are some issues that come with that, in that when you put oil down here, it's very easy for it to leak onto the slide grease, and then when those two mix, it will thin out the slide grease a lot, which as I was mentioning before, can really affect how well your horn seals, depending on the tightness that the maker of your horn prefers.
Yeah, so sometimes if you give your horn a bath and you change all the greases, you'll notice that your slides, the grease wears out really quickly. And it's because the oil that you've just freshly put on the rotor leaks down and then dilutes the oil in the slides.
Yeah, and so it has benefits and drawbacks. On the one hand, your rotors will seal better if you have ample oil on the surface of them, but on the other hand, your slides might not seal as well. So it really is a trade-off, and I'll get into more of that later. And then valves, I won't mention that. So, and then slides is not really too complicated. There's different, as I was mentioning before, different horn makers may prefer a different tightness of their slides. So like on my Yamaha horn, the slides are really tight from the factory. So I don't really have very much grease on here right now, but you can see they're pretty hard to move. Because I have not greased them in a while. But some other horn makers say that, or just make them so that there's more of a gap, and that the grease is then meant to fill that gap and create the air seal. And so if you have a horn where the slides are less tight, and also if it's older and they're less tight, it's generally best to use thicker oil. And then, like I was saying before, you should really just grease whenever your slides are feeling like the oil is too thin, like they're maybe falling out, or they're not staying in place, or sometimes even if they're too hard to move. And really that's because if you don't have enough grease on your slides and your rotors too, they'll build up corrosion much faster, because all the water and stuff will be able to get into the surface of the metal.
Internally and externally. So, so if you don't oil your horn regularly, you'll actually get a lot more green stuff inside of it.
Yeah, so not only will stuff probably not work as well in the short term, but it'll also need chem cleaning more quickly in the long term. And then stoppers / felts and corks. I won't talk about felts and corks again because there's not really any valve players here. But for stoppers, this is something that I've done a lot of research into and I think is very important. So basically, there are different kinds of materials. The most common is something called Buna N, or sometimes neoprene is used as well. And those are pretty good. But the problem is that over time they'll absorb oil. And when your stoppers absorb oil, they'll expand so that the rotors don't line up anymore when you press them down. And that can affect how well the horn plays. And with that, you have your hardness. And the hardness of the stoppers can affect how loud they are, just cosmetically, and it can also affect what I'll get into in a second, which is how much bounce they have. Generally, you don't want to have too hard stoppers because they'll just be loud and annoying. They won't feel great. But you also don't want to have them too soft, because that will potentially be even worse, because they could swell up with oil or something like that. And for bounce, we actually have a video of Dr. Sirkin's horn. This is a slow-mo video, so you can see the type of stopper she has. When the key is pressed, every time it goes down and comes back, it just bounces a little bit, and that's fine. It's not super horrible on Dr. Sirkin's horn, but it will decrease the responsiveness of your horn the more bounce you have with your stoppers and on your rotors. So like if you notice they feel like really like jiggly when you're pressing them, that's probably not a good thing, because it's really going to mean that you're not going to be able to play things quickly or smoothly as well as you would be able to.
Does someone want to talk about alignment with that?
Yeah, and there's different, I mean, it's fine.
Okay.
Yeah. So yeah, and now we're gonna get on to the issues section. So that's just general maintenance stuff. There's not really too much more you need to do on your horn, to your horn on a regular basis. But now we'll get into some common issues that people will have. So one of the most common things that I hear about is loud rotors. And so that can be caused by a couple things. So it can be caused by one, the top bearing plate, which if we go back to our diagram over here, it's this metal thingy that goes on top of the rotor, in between the cap and actually inside of it.
You can show the disc.
Yeah, oh. So, and if you see on Alex's horn, they are these things right here that go on top. So, if those are not leveled correctly, then they will actually sit too high up, and when they sit too high up, that can cause a couple of problems. One, the air is not going to seal as well because it's tapered, that those two surfaces won't really be in contact the way they're supposed to be.
And what do you mean by level?
And by level, I mean it's going to be hard to show, but when you have to take out the rotors, you have to take these off, and when you have to put them back on, there's generally different kinds of tools that you can use that will just sort of go around it, and you can just hit it. Normally what I actually do is I'll just take a valve oil cap, and I'll put it on here, and I'll just hit the top of the valve oil cap, and that will help it sit better. Sometimes if you notice one of your keys is getting really loud, and you open it up and you see, oh, there's kind of like this little gap on there, and then it could be that you need to re-level it, and you could maybe do that yourself if you just, like I said, use a valve oil cap, but that can also be not good because it can then get misaligned. And then it can also be caused by rotor wear, which is really unavoidable. If you play a horn for a long period of time, just by the nature of metal on metal contact, the rotors are going to get worn away. And there's really not much you can do about that other than use thicker oil, or if it's really bad, you can get them replated, and that's just what I mentioned here. You can use thicker oil, or just oiling them. Sometimes, like I know for my horn, even though it's a pretty new horn, I got it like 2 years ago or something. If I don't oil them regularly, the rotors will be super clicky just because they're not oiled well. And then it can also be caused by linkage. So sometimes if you have a two-part linkage on your horn, which I can go to this one. So this is a picture of my horn. I guess I can't really zoom it in anymore, but you can see there's two parts to each of the linkages. Yeah. So, I'm sure most of you know what this is. And sometimes you have one-part linkages, and those are often a lot easier to work with. But sometimes the problems with loudness can be caused by that linkage being too loose. Another thing that is probably the most common thing that I see that causes rotors to be loud is string problems. So if the string is not tight enough, or it's too tight even sometimes, it can cause the rotors to be really loud because either the key will be just kind of wobbling around, or the arm on the rotor will be just kind of wobbling around. Or if the string has too much tension, it'll make it really hard to press them, and that's not good either. And then the last thing really is ball type linkage problems, so mechanical linkages as they're often called. So a lot of horns might have them on their trigger, like Con 8Ds. Most of the newer ones have ball type linkage. They use good ones. So Hans Hoyers have a ball type linkage on their thumb key, and so those can get worn out, and in the case that those get worn out, there's really not all that much that you can do. Sometimes you can put little spacers on it or put thicker grease on them, but generally you really can't reduce it, and you might have to get, I might have to replace that little linkage. And there's different
Or convert
kinds of link, or convert it to a string linkage. And there's different kinds of linkage. So there's like, there's the mini bowl type where they're like steel on steel. Those ones are fantastic. They almost never get worn out. But then there's like some other ones like what the Hans Hoyer use where they have a brass casing with a harder metal ball on the inside. And because the metals are different hardnesses, it gets worn away really quickly and it can cause it to get really clicky, which is obviously not good and contributes to loud rotors. The other one is heavy rotors. So sometimes this can be caused by too thick of oil. I remember Hayden, not to pick on you Hayden, but he had the Hans Hoyer rotor oil and he had been using it and his keys were really, really slow. And he was like, hey Ethan, can you check this out? And the Hans Hoyer rotor oil is like too thick, like way, way too thick. So his keys were just
slide grease.
Yeah. Yes. Yeah, so using thinner oil can help with that sometimes. Also, if you're not oiling frequently enough, that can cause your keys to be slow because corrosion will build up.
Especially with the non-synthetic oil.
Yeah, especially with non-synthetic oil. If you're not oiling them frequently, then it can cause a lot of problems, causing them to be heavy or slow. And then oftentimes chem cleaning is needed in the case of you not oiling frequently enough and there's corrosion buildup. So I know for me, I've had some issues where for like the whole beginning of this year, I had like fallen asleep after bathing my horn, and so I didn't get the chance to dry it off and put it back together. So it was like 3 a.m. And so like the whole like first like probably like 4 months I was here, my keys were just like they were just like really slow because when I had let it out with none of the slides in and the water on it, that had created corrosion on the rotors that just really wasn't going to go away from me using them. So
and when you talk about corrosion, you're not talking about green stuff. You're talking about when it turns brown and black.
Yeah, so I mean, obviously the first stage to tarnishing of brass will be that it'll turn brown from like the sort of lighter color, and then it'll eventually turn black. Sometimes you can build up the green stuff in the rotors, but most of the time, like if you see an Alex's rotor, that'll be inside of the port.
Yeah, it will be on the face because the faces.
Yeah, and actually this is a pretty good example. You can see how the rotors are sort of darkened, but when you give it a chem cleaning, that'll take all that away, and they'll be much faster. I was really surprised when I first chem cleaned my horn at how much faster the rotors got just from being greased properly, or for being like having the corrosion taken off. There's valves. I'm not going to go over this because there's no outliers. So for slides, there's a couple things that can be issues. So, well, I just wrote this one thing. I'll get into some other like that stuff later. But misalignment is really the main thing that you can have with slides. So sometimes you can bend it yourself. Now that is not generally advised because what happens when you bend a slide is that not only are you bending the two ends of it closer and farther apart, but you're actually changing how round the tubing is. Because there's no support structure inside of it, that tubing will get more and less round.
Unless there is a support structure.
Unless there is something in it. But, and that's not good because it can change how the frequencies go in your horn and how well it resonates and how in tune the partials are depending on the importance of whatever slide you're bending. So you can do that if it's not too bad, but it's generally not advised. And sometimes what you can actually do is if it's, the slide feels really tight, you can just thin out the grease a little bit and just work it back and forth, and sometimes that'll fix the issues like completely. Just doing that.
So a way that you can know if your slides are out of alignment is when you take it out, if it kind of pops out with, so your valves are down. Let's say you're taking out a slide, your valves are down. So you're not running the risk of compression issues. So you pull it out and it's still a pop and there's kind of a ring afterwards. And that's how you're going to know your slides are misaligned because it's going to feel, so let's say the slides are bent out this way. It's going to feel more gritty because there's only one point of contact on the sides. And two, you're going to hear that sort of ring after you pull it out and that pop. And so that's how you'll know.
Yeah, and one of the reasons that's bad is not only does it make your slides worse, but also when you have that, you're having tension introduced into your horn, and when there's tension introduced to your horn, it sort of, to my understanding, traps those vibrations that might happen, and anytime those vibrations are happening, obviously your horn, those are trapped, your horn is going to feel and sound less resonant. It's just not really going to play as great as it did. And something as small as just your slide being a little bit out of alignment can really affect that.
And not even just to your understanding, through experimentation with rebuilding your horn.
Yeah, I'm rebuilding my horn, yeah. And so now we're going to get into a pretty big section, dents.
Can I ask a really quick question?
Yeah.
As far as giving your horn a bath, how often do you do that?
So for me, because I have the ability to chem clean it, I just chem clean it. Wait, what?
For us,
Oh,
do you recommend?
Yeah.
Probably every 2 to 3 months, I would say. It's not going to need it too often.
It really, okay, I will say though, it depends. Because if you have a lacquered horn, it's a little bit different. If you have an unlacquered horn, it's much easier to bathe it. You don't really have to worry about anything because it's not like the lacquer's going to peel off. But if you have a lacquered horn, it can be dangerous bathing it sometimes because it can be damaging to the lacquer if it's left in there for even just a little bit too long. Then the lacquer can get cloudy because some water can get trapped under it. Every 6 months is advised, but I generally find every 4 to 5 months or 2 to 3 months, depending, can be best for bathing. It's really just good to clean out your horn and get it all nice. But
Would you recommend dish soap?
Yes.
Yes.
Okay.
So actually there's a couple things. So I would recommend dish soap, especially because dish soap is it's soap. It's a type of thing called a surfactant. So basically any grime that's on there, it will create a layer between the metal and the corrosion and stuff, hopefully, especially if you were able to break it apart with a little brush or snake or something like that. And also, yes, also if you have a horn that does not have lacquer, I don't know how this would work with a horn with lacquer, so I wouldn't try it. But if you have a horn without lacquer, what you can actually do is you can put some baking soda as well as the soap in there, and what that will do is it will neutralize any of the remaining acids in your horn, because baking soda is basic, and your hand oils and the air and stuff is generally a little
Sometimes
bit acidic.
saliva too, yeah.
Sometimes your spit as well is acidic, and that is what causes the corrosion to build up in the first place. So if you actually bathe it, if your horn is unlacquered in a solution of baking soda, dish soap, and water, then it will prevent that from happening for longer, the
And-
tarnishing.
Don't be afraid to get soap inside your horn, completely inside your slides, on the valves, everything. Don't be afraid. Just make sure everything is completely washed out, but the soap won't hurt it.
Yeah, with a lacquered horn, it won't either, but again, just really anything with water in a lacquered horn, you have to be more careful about in general. That was one of the reasons I wanted to get my horn unlacquered, because I didn't want to have to deal with the lacquer getting messed up. So yeah, and now I'll get into dents, and anybody can ask any questions at the end if they want. Sorry for talking a lot. So here's dents, and I'll say why dents matter. I mentioned it a little bit before. So whenever there's any change to the diameter of your tubing, number one, it can change the resonance, because a round tube has a certain resonance pattern that might be ever so slightly altered if the tubing is not perfectly round. So if in the case that you have a lower quality instrument, like some cheap Chinese $300 horn or something, then the tubing might not be as round, and that's generally why those sorts of horns sound bad. And then a dent can also have a similar effect on it, where it causes the partials and stuff to not quite sit where they did before, and I think that's bad for obvious reasons.
Like your partial spacing will be wrong.
Yeah, now probably not that much, but enough sometimes that you can notice it. And also can restrict the airflow depending on where it is, or depending on the severity of the dent. And you really don't want the airflow on your horn to be restricted, because that's just bad. You'll have a more close sound, and it will just be more difficult in general to play it. So here are the main kinds of dents. So there's slide dents, which I'm sure you guys know are on the main tuning slides, and it's a little bit different for Hayden's horn and these kind of slides, the valve slides. So those ones they're fairly important, like I said, for the restriction of airflow reasons mainly because they're pretty small diameter. But they must be taken to a repair shop to get fixed. There's not really any way that you can fix them yourself. But they're not particularly difficult to fix.
The other thing is that slide dents, unless they're on these little knuckle tubes, slide dents, they're probably never going to be perfect. So if you dent your slide, you take it to any repair tech, there's a very low possibility that you're not going to, it's never going to be the same. It's never going to be like it came from the factory. And that's just because the tools that repair techs have available now are not able to get the dents out all the way. So you'll have tubing that is 0.472 inches in diameter. And they make balls that might be 0.470, so 2/1000 of an inch off, or 0.4725. So that would be 5/10,000ths too big. And the case is that even if your manufacturer's spec is 0.472, that 470 ball might not even be able to fit.
Yeah, because of the way most horns are constructed. Unless you have like a Medlin horn or something like that. Medlin, I've heard his slides are amazing. But most of the time, like I said, with bending and tubes not necessarily being perfectly round, the dents in the slide might not come out all the way. And also some balls that you would think should be able to fit in there might not even fit in there because stuff isn't really made perfectly. And and then further on, there's bell and bell tail dents. So they can be pretty important if they're on the bell, because really what the bell does is it amplifies those vibrations a lot because it spreads out the sound and also has a large surface area that can resonate. Some of them can be made better or repaired by hand, but you have to be really careful, especially on a detachable bell horn. It's a lot easier to do this. So what I'll do sometimes is I'll get something like a cloth or sometimes like Vaseline, I know that's kind of weird, on my hands, and I'll just put my hands like this on the bell, and I'll have it on my leg, and I'll just kind of roll the bell on my leg, and that will actually make most of the dents on a bell much better.
It works for softer and thinner bells. So our Yamaha horns, for example, are super thin, and I don't know if you guys have ever seen those repair videos with like dent rollers or whatever. So French horns with thinner metal or softer metal, you can't use dent rollers because it'll create a crease in the metal where the dent roller was. So you have to take them out with hand or with hand burnishers. But not everybody.
A burnisher is just a metal tool that's really smooth that you use to.
Yeah. So.
We
But-
don't need to get this. We don't.
Okay,
Get okay. It does not matter. Further up the bell tail and more complex dents, you have to take them to a repair shop, but they're generally not that hard to remove. And then lead pipe dents, generally very important. That's where your air starts from, and it's the smallest part of the tubing. And the taper of the lead pipe really affects how a horn plays, and so they're generally very important, and they must be taken to a repair shop. There's not really any way that you can fix them on your own. But they're not super expensive unless they're really severe, typically, or at least I wouldn't charge a whole lot unless it was really bad. And then other dents, which would be any sort of dents on like this tube, like going into the first valve, or if I flip it around, like this one, or like that, or going into the
Big one's the
F
bell
branch.
tail.
Yeah, or the bell tail, so coming down like, so near the top of the bell tail and then going around there. Those are the other kinds of dents. They can be pretty important depending on the location, and they have to be taken to a repair shop. Like I said, most of these dents, there's not really any way you can take them out yourself. And they can be quite in-depth or inexpensive depending on the location of the dent on the horn. So like if it's far down on the bell tail or after the bell tail, you see there's this thing called a ferrule which connects this one, this tube, and this tube. And on this one, those can be quite in-depth to take apart. And having to take apart my horn to get out a dent on here is actually what caused us to have to rebuild the whole thing, because it's just really hard to align them. And also,
Causes, there's a factory defect.
well, yeah, there's some factory defects too, but also like this F branch one, which is this tube that comes out of your first valve on the front, and those ones also are quite in depth to take apart. You have to unsolder a bunch of stuff. So just hope that you don't get a dent like that, I guess. And then last thing, I know it's finally over. Lacquer, what it is it's a thin, clear, or yellow tinted layer of either epoxy or nitrocellulose. You don't have to know what that is, you just have to know it exists. It doesn't resonate in the metal with the metal of the horn in the same way because it's much harder and it's just a different sort of structure than the brass is, obviously because it's a different compound. So it can cause a less warm sound because the lower overtones are reduced by the harder lacquer surface. And if you have a horn that has really thin lacquer, it doesn't really matter that much, but if the lacquer's thicker, it can really start to affect it. And it's meant to protect the metal from being eaten away by the air and acids from your skin, which is like, I've mentioned that before, just the metal getting eaten away by stuff and getting corroded. And so if you have any spots where you're missing lacquer, they'll begin to tarnish, so they'll begin to get more brown. They won't be so like bright yellow anymore, or if you have like a horn like Hayden's, bright silver, I guess. And if the lacquer is missing from frequent contact with the hand, so like say you have it on the inside of your bell or like at the top of your horn, like where I have this little wrap right here, or
Why don't you show the color?
on this horn, you can see it's all pitted up here from where, this is the studio con that we worked on, and there's a lot of wear under here, and it's just from grabbing it with your hand. Those ones are really important spots to take care of.
And that pitting, it really only happens when you have a lacquered horn? Okay.
Yeah, it really generally only happens when you have a lacquered horn or a really old unlacquered horn. And then, like I was saying, they'll begin to tarnish. The metal will get unevenly worn away, and the metal can get pitted over time, so it's important to frequently coat that metal that there might be missing lacquer from with some valve oil or rotor oil. Like I'll just get like an old white t-shirt or something, really any cloth, and you just kind of rub in the valve oil, and that'll soak in, and it'll have a similar effect to the baking soda when you're bathing an unlacquered horn, where it sort of prevents any water or acids from getting inside the metal and causing it to tarnish and pit. So that's pretty much it. Again, I'll just go over, you can see this is the studio con, so this is the bell tail going into the bell, and you can see it's really worn away. What happened here is that somebody's hand was kind of holding it and touching right along here for a really long time, so the metal got really thin because it was eaten away, so we had to put a patch on it right there, and then you can see that patch from another angle, and then you can also see this was one where there was where there was really bad pitting underneath this patch that we made to go along here. And you can kind of see it up here just from frequent contact with the hand. It caused the metal to get worn away and pit, and that's just really not good. But yeah, that's it.
Question, to what extent do patches impact the sound?
So it depends. The solder that you use is very important. So with lead tin solder, it's all right. But what you really want to have is, so there's solder. Solder is a silver colored metal that you melt to connect all your connections. So that's all your ferrules, everything in the horn pretty much is soldered together. And there's different types. So there's a lead tin alloy, which is going to be softer. And then what I use and what a lot of horn makers use is a silver and tin alloy.
This one.
Yes. So it's something like 3% silver and then 97% tin. And this has a much higher tensile strength, which means it's harder than the lead tin solder. This higher tensile strength is closer to brass. So you want a solder that's going to vibrate well with your brass. So moving on from that, adding more mass, it depends on where you're adding the mass. If it's just a little patch, it's not really going to make a difference. If it's a huge patch on the bell tail, it can make some difference. It might dampen the sound a tiny bit, but it's really not going to be something you can hear unless your horn just has patches all over it. But again, the most important thing with horn construction and patches is using the right kind of solder.
Yes, and also making sure that the metal underneath the patch is not still dented in or anything like that, and just making sure that the inside of the tube is very round.
And with our Yamahas, there's lead-free solder, which this is a type of lead-free solder. There's multiple types of lead-free solder. Yamaha uses their own type of solder. It's not very resonant. So when we went through and rebuilt Ryan's horn, we used that solder that's more resonant. It makes the horn ring a lot better.
Mm-hmm. Yep. Any other questions?
How often should you be putting like valve oil or whatnot on an unlacquered horn?
So an unlacquered horn, if you want it to stay shiny, you should be putting it on pretty frequently.
I would
But
say like maybe once a week, once every 2 weeks, at the longest, if you really want it to stay super shiny, or just protect it really, because it will get worn away just from you touching it over time. Some spots less than others, but yeah.
some people use like hard waxes, like on the inside of their bell and where their handguard is, and that just protects the metal even further. But another thing is that once your horn gets fully brown, like mine has gotten a lot more brown than Ryan's. Ryan's is pretty shiny. That layer of oxide on the brass is actually going to be harder than the brass underneath it, so it will serve as a sort of very thin layer of protection.
What does the process for unlacquering look like?
Oh, I can airdrop you some photo. I'll do the bass drum bone. I'll show you.
Okay, yeah, so it really depends. Some people do a submersible lacquer stripping solution, so it's less concentrated and it's just a liquid, and you just put it in a big vat and just put the horn in there and you leave it. What Ethan and I do is much different. I think that it's a lot better. It's a thicker sort of solution, so it's basically like a little paste in this big like chemical bottle. Like, do not touch, because if you touch it, it'll burn you. It's not fun.
Yeah, it does give you chemical burns, so you have to be careful. You can't wear latex gloves or non-latex gloves because it will burn you through that.
Yeah, but we just are very careful and we just paint it on, and then
So,
it comes
okay,
off.
I'm going to airdrop you this photo now.
And we unlacquered a friend's trombone recently. If I can pull it. Oh, that is not what it. Oh God.
Oh.
I'm not sure I understand.
Oh, I'm sorry that's true.
Awesome. Wait. Wait. Oh no. Wait. Can you read?
Yes. Yeah, I got you. Oh, you got all of them. Multiple times. Okay.
So yeah.
So once you paint it on, after about 5 minutes, the lacquer is going to start sort of peeling off. And what this is it's a thin coating of plastic, which is what lacquer is. It's a thin coating of plastic.
Like I mentioned before.
Yeah, and it's coming up, and it's wrinkled because it's expanding. And you can see here, this was one section that I had painted more recently, and this is something that I had painted longer ago. And you can see this one's all wrinkly, and this is where I haven't touched it. So wherever the solution touches, it's going to strip that lacquer. Once you wash away, it's...
Oh, and you can see down in the corner here we have our paintbrush and little thing that we used to paint on.
It's actually
You're
really
kind of
simple.
covering.
Oh yeah, sorry. It's a pretty simple process, but the hard part is what comes after it. So you have to wash it all off, and then the metal under will be shiny.
Oh, you can see some of it peeling off here, and you can see when it peels off, it's not any less shiny. It just doesn't have that plastic coating on it anymore.
Yeah, and you can see there's some spots. So whenever you remove lacquer, the metal under is actually, it's spotty because there's still some like remnants of like chemicals, and it's not perfectly polished. It looks really good. So you have to go back and hand polish a lacquered horn, or a recently unlacquered horn. You have to completely do the whole thing. It's a little bit more in depth than just like a touch-up polish, like I would do on my horn if I wanted it to be all shiny. It would be a lot in depth, more in depth than that. But yeah.
Can you talk about pros and cons of a chem clean versus ultrasonic clean?
Yes.
Great question.
We learned about this from Mike Morse, who's at the Tubing Exchange. So basically, a chem clean is going to use very strong I believe it's an acid actually, to break down all of the corrosion on your horn, which I guess is kind of counterintuitive because the corrosion and oxidation is caused by acids in the first place.
It's limescale buildup, which is
Basic, yes, versus acidic. And so a chem clean will be able to get all that stuff off pretty effectively. However, if you leave it in there for too long, it can cause the metal to get really pitted because it'll essentially accelerate that process of your hand touching the metal over time.
I will say that I use a brass tube to stir my chemicals. I left it in there for like a week, and it just it kind of got dull. Like it didn't.
It's kind of hard to mess something up with a chem clean. With ultrasonic, it's more easy to mess stuff up. So, an ultrasonic there's this big tank, well, I guess it doesn't have to be big, but, you put it in this tank, and the tank has like a little metal cage, and it just vibrates stuff really fast. I don't understand exactly how it works. It's water, yes.
Yes, but so the thing, sometimes it's not. Sometimes it is this chemical solution. And so what Mike Morse said he does, and this is how ultrasonics are performed, is you're still using those chemicals. You always use the chemicals. The thing that the ultrasonic does is, once you use the chemicals, there's all this debris and kind of brown, it's almost like a film. And you can use brushes to get that out. It's effective. You can wash it out. It will all come out. So as soon as you wash out your slides from a chem clean, the water is going to be muddy, whereas if you hadn't chem cleaned it, it would not be muddy. So there will be a period where it's muddy and washes out all that particulate. What the ultrasonic does is it cleans out all that particulate to an even higher degree. So you'll chem clean it for 5 minutes, which is how long it has to stay in there. Chem clean it for 5 minutes, put it on ultrasonic, get all that gunk out, maybe do another cycle or another cycle depending on how dirty the horn is. But it's me saying that a chem clean and an ultrasonic are essentially the same thing. The ultrasonic might get it a little bit more clean, but not a consequential amount.
Yeah, and then an ultrasonic can actually be pretty damaging to your horn, because if you have any spots where the metal's thin or there's red rot, which is another name for it is dezincification, because brass is an alloy of mainly copper and zinc, and so what will happen is that zinc will sort of be eaten away and it'll just leave a more porous copper structure underneath, and that's what red rot is. And so if you have any spots like that, or any spots where the metal's thin, it can really damage that, and it can sometimes just blow through it, just cause you to have a hole in your horn, is what Mike Morse was saying, I believe.